This is Chapter 15, Real Estate Math, and these are the review questions at the end of the chapter. I thought I'd go over these to kind of do a review for you in case you had any questions trying to solve these. So I'll take these one by one and go through and I'll give you the keys to answering these questions. Okay, the first question is a homeowner secures an improvement loan for $3,600 payable over 3 years. So it's not interest only, it's payable over 3 years at 15% per annum. What is the amount of the third payment? Okay, so it's not interest only. It's 36 months. So 36 months. So you are paying principal on a monthly basis. So 3 years times 12 is 36 months. If you divide the 36 into 3,600, you come up with $100 a month. So you've already paid $200 on this loan. So let's look down here at our key. So 3,600, you've paid $200 for the first 2 months. That leaves $3,400 that you're going to pay your interest on for the third month. So 3,400 times 15 is 510. 510 divided by 12, because we're just going to make one payment, is $42.50. So if I take my $100 principal I'm paying plus my interest for the third month, the answer is $42.50. $42.50 for the third month, principal and interest. Okay, now we're starting something new. It's referring to question 1 again about the $3,600. And it's saying, well, what if that loan was paid monthly interest only, meaning I'm not paying any principal balance on it? With the balance due in full at the end of 3 years, what would the total amount of the balloon payment be? Or really simply, you're paying interest over that time. You're not paying any principal and interest. So you're not paying any principal. So at the end of 3 years, you truly owe $3,600. But they're making this a little difficult for you. So you know it's $3,600. Plus you're always paying interest in arrears. So you're going to have 1 month where you owe the interest plus the $3,600. So what you'd want to do is find out what your interest is per month. So I've got $3,600 times 15% is $540. Divided by 12 is $45 a month. So I do owe my $3,600, plus I've used that money for the last month, which is $45. So my last payment due is the entire principal, since it's interest only, at $3,600 plus 45. So I'm going to go $3,645 for my last payment on the interest only loan. Okay, number 3 now is regarding add-on interest. So the loan amount in question 1 is designed at 15% add-on interest. What is the amount of the third payment? So first thing we have to find out is what's the principal you're paying, because you're paying a principal payment monthly. So it's 3 years times 12 is 36 months. So if I divide 36 by the 360 principal, that's $100 a month. Then I have to find out how much 3 months interest is. So if I take the 3,600 times 15% per annum, that's 540. Take the 540 divided by 36, that gives you $15 a month. 3 months interest I'm looking for. 3 times 15 is 45. So now I go back to the top and take my principal payment of $100 plus the 3 months at 15, $45 a month. So my total payment the third month would be $145. Okay, number 4 relates to question 1 also. It says it's designed at 15% add-on interest rate. What is the effective interest rate? Well, there is a way to guess at this, because you remember that what the book says is almost double what you're paying. So if I was going to guess at this, I know my rate is 15%. Double that would be 30%. So which one of these is almost double? Probably going to be this one. Now for this question, the only way to solve it is actually go back into your book and look for the add-on interest rate formula, which is 2 times the term times the annual interest divided by the loan amount times your term, 36 plus 1. So that comes down to 12,960 divided by 133,200. If I do that, it comes out to 29.19, moving my decimal point for percentage, 29.19%. So my guess was fairly accurate for the add-on interest rate. But once again, the only way to do this is either do a calculated guess or go back and use the formula. Question 5 deals with the present worth of an annuity. And what they're giving us is this, is what is the annual payment required to amortize a $100,000 loan at 8% interest for 20 years? So what is that payment? And that's the description of a present worth annuity. So I know I'm under 20 years and I'm on an 8% table. So what monthly payment or deposits of an annuity would I have to make gaining 8% over 20 years to come up with my value of $100,000? And in the book, it says that the payment times the factor, right here, 9.8181, is equal to $100,000. But I don't know what the payment is. So using a little simple algebra, if I divide both sides by my factor, ultimately I would divide my factor into $100,000 and come up with $10,185. So that's what I would have to put in the bank annually at 8% interest over 20 years to come up with $100,000. And that's the present worth of an annuity. Question 6 says, what is the amount of a single deposit into a savings account at 8% interest to accumulate $50,000 in 15 years? So I know I'm over here in my 15 year and I'm at the future worth of my money. So I'm going to use this factor right here. So what it says is that $50,000 is equal to the beginning deposit times the interest rate factor. Well, I don't know what the beginning deposit is. So what I'm going to have to do is $50,000 is equal to the beginning deposit times the interest rate factor, which is this. So once again, I have to divide by the interest rate factor from both sides. So $50,000 divided by 31521 is equal to 15,762, my initial deposit, my one-time deposit at 8% interest over 15 years. Then I'll have $50,000. So just take your end value desired, divided by the factor, 3.1721, and that'll give you the amount you have to put in the bank today, 15,762, and wait 15 years at 8% interest to accumulate $50,000. Number 7, this has to do with, let's read first. What is the amount of the regular annual payments? What is the amount of regular annual payments into an 8% interest savings account needed to accumulate $100,000 in 20 years? So we're talking regular annual payments, and we're looking for the future worth of $100,000. So I'm going to go up here, future worth of an annuity, because it's regular annual payments. And if I want to find out how much the payment is over that period at 8% for 20 years, I divide my factor, 45.7619, into $100,000 and get regular payments of $21.85. A mortgage constant is a computation of an annual payment needed to amortize a loan. In this case, on number 8, we have a $100,000 loan at 8% interest over 15 years. but that's the payment for the loan. The rent for the loan is 8% over 15 years. But what if I want to amortize that loan and pay it off over that time too? What would my mortgage constant be to allow me to do that? So if I do that, I'm going to go up to my table here under 15 years for the present worth of annuity and grab this factor, which is 8.5594, divide that into $100,000. That comes out to 11,683.06. Okay, so that's going to be my principal and interest to amortize the loan and pay it off. So what interest rate would that be then? So if I'm going to take a percentage of $100,000, what percentage of that is 100,000? So if I divide my $100,000 into this number I came up with, it comes up to 11.68%. So that's the mortgage constant for $100,000 to pay that loan off in 15 years. Question 9. At an 8% interest, what is the present worth of a property generating $20,000 net income for 10 years? So what's the present worth? So I've got 8% table up top, and I'm going to look for 10 years. Present worth is, the factor is 6.71. So if I go over and take the $20,000 times the 6.71, then my beginning worth of that property is $134,200. Question 10. At an interest rate of 8%, what's the present worth of a property generating $5,000 net annual income for the first 5 years, for each of the first 5 years, $750 net for the next 5 years, and $10,000 net for each of the final 5 years of the 15-year lease? And then additionally, when the property is expected to have a residual net cash value of $100,000. So in a nutshell, we're going to have 4 values to add up to come up with that total value. The first 5 years, which is the 5,000 times our factor up here, years 6 through 10, which would be this factor, 2.7173, and we get that from subtracting 6.71 and 3.9927 to give us only years 6 through 10. And likewise, we do the same thing for years 11 through 15, multiplying by 1.8494, which is the difference between 6.71 and the 8.5594. And then for the net residual cash value, we'll go back up here for 15 years and use this factor, 3.1721. So then that taken all together, we have years 1 through 5. There's the value, $19,963.50. 6 through 10, $20,379.75. Years 11 through 15, $18,494. And then the net residual cash value is $31,520. So if you add all those up, then you get $90,357.25.